Okay. Yeah. Hi. Good evening, everyone. Myself, Anamika Kadam, as Governing Council member of IS Tracti and practicing civil engineer of Larsen & Toubro. Welcome our key speaker, Mr. David John Burgess, and our esteemed audience who all have joined us to get hooked to this very interesting and informative session today. I would also request our audience to put through your queries and questions whatsoever in chat box, so that in the end of the session we would be able to take up all these queries one by one. So now let me start by giving you a simple brief of the topic today, that is achieving sustainability through modern methods of construction and low carbon technologies. What is it? The need to achieve modern methods of construction, that we will be using MMMC as a short form of modern method of construction, will push the boundaries of engineering whilst ensuring a safer, sustainable and economical approach to deliver future structures. Today, our key speaker, Mr. David, will take us through a deep dive of these sustainable MMC solutions around the globe. Mr. David will further explain how digital development of structures are vital in the pursuit for achieving sustainable designs. David hopes to inspire the present generation of opportunities to take up the challenges towards adopting modern methods of construction in India. So, with this interesting topic, let me also brief you about our speaker, Mr. David John Varghese, today, to share his learnings and experiences. We have with us Mr. David today, and he is a chartered engineer with the Institution of Engineers in the United Kingdom. David is actively pursuing projects to future implement the use of modern methods of construction. He has demonstrated his technical expertise in the successful development of MMC with the use of design for manufacturing assembly systems within Hong Kong. David has developed cost-effective and sustainable solutions for his clients that focus on low carbon structures paired with low energy technologies. His proven analytical insights of structural behavior contributed to critical design improvements at the conceptual design stages. So that's it from my side today. I will I'm now welcoming Mr. David John Varghese to come on stage and to present his very, very informative lecture to all of us today. Welcome, Mr. David.
Hi, thank you, Ms. Anamika, for that very good introduction. I will just start to share my screen and we can take it from there. So I hope everybody can see my screen. Please let me know if.
Yes, we can see.
Yes.
Right. Okay, so I'm just going to start by just saying thank you for taking the time to join this session today. I am thankful to the Indian Association of Structural Engineers for having me here today to present a topic which focuses on sustainability in construction. I also thank my dad, Mr. Varghese, for asking me to do this, and hopefully make all of you, or at least some of you, think about how we can do better to improve sustainability in the work we do on a daily basis. Slide. Right. The presentation would approximately run for 50 to 55 minutes, with ideally a 5-minute break somewhere in the middle if it's required. The session would ideally be divided into an introduction of about the industry in terms of energy usage and the needs for MMC. And then I would briefly explain what goes into achieving project delivery based on the systems used, such as BMS, which is Building Management Systems, and along with some examples of energy storage that interest me. Lastly, I would show a few interesting projects that I worked on, and they're also part of MMC and digital delivery in Hong Kong, and some interesting marketing videos they have generated for us to enjoy. And finally, with the close on thought of what the future holds for MMC and energy storage. So this slide I present to those aspirants who would like to look at what checkboxes they would need to achieve throughout their career, similar to if you like what I do. So if you choose to take any of the engineering pathways, you would ideally want to be a part of a professional institution, whether in any part of the world, as all parts of the world have a system of professional institutions. That is the ICE in the UK, the Institution of Civil Engineers, you've got structural engineers. Similarly, in India, you've got the Institution of Structural Engineers, as well as the Institution of Engineers India. So I would encourage all of you to join such a community and member and improve the way we do work or deliver our projects and improve the quality of how we design things. So I became a chartered member of the institution in 2021, and before that I did completed my bachelor's in 2013 from NIT in Jalandhar. I did my master's in the UK in 2015, and I spent 4.5 years working in Hong Kong, and then I'm presently working for a company called WSP in the UK in the civil and bridge engineering team. And some of the major projects I did work on was the longest open sea fixed link in the world. That was 55. Let me just try to bring a pointer up. That is 55 kilometers long, this bridge here. And then similarly, another project was something which allowed me to do more of bridge erection and post-tensioning. And then further moving on, I did the longest deep sea tunnel in the world, which is connecting the airport to an island. Then another one, very important one, which is very recent in the past 2 years, was Hong Kong's pilot project, Model Integrated Construction. This was a 17-story building, which was completed structurally in 7 months. And then presently I work on the HS2, which is a high-speed rail that connects London to Birmingham, and further it connects Leeds and Manchester. So by showing this, I'm just trying to say that, if you have the opportunity to travel, take the time to do so. The experience is going to be well worth it. And such is mine, as you've seen. And most of the times these projects tend to be extremely challenging, but once you do them, you realize that the experience you've gained is going to be really memorable. And now I start with India's post-COVID recovery strategy, questioned by what happened just after COVID and how the construction industry was affected by it. When that happened, many businesses or many professional audit advisory companies like KPMG, which is the example I'm presenting here, they asked these questions of how do we recover from COVID? And what the point is what are those questions we ask, such as what kind of project do we prioritize? What is the project definition and the delivery strategy? How do we build resilience? When we say resilience, it just means how do we create an environment where another COVID happens, we should be not affected by it. And how do we create contracts that allow such a scenario where it is less affected in terms of contractually by doing projects which can be affected by COVID. And they towards the end of COVID, they came up with services, or they are still providing services that carry out such processes where they do COVID-19 impact assessments, and then they work out strategies, and they do digitally enabled portfolios and project transformation. And then finally, they say a point which is setting up an outcome-driven program and program management office. I'm just trying to tell the audience to remember this, because I'm going to show you what the UK's COVID recovery strategy is, which is basically similar. And this is what KPMG has to offer. And there are many companies which are following the same principles to get through COVID, as we are still recovering from COVID. And because of that, so we have to understand how are we going to do this. Then the topic of Build Back Better comes out. So this was a webinar called the Green Recovery of Indian Economy. And the foundation which manages it is called PAGE, and they provide integrated and holistic support to countries eradicating poverty, increasing jobs, social equity, strengthening livelihoods, and environmental stewardship, and sustainable growth. So this program is adaptive and aligns with the national priorities to offer tailored and effective support to transform economies to advance to 2030 agenda and the Paris Agreement on climate change. So PAGE is the Partnership for Action on Green Economy. It was launched in 2013 as a response to what at the Rio +20 to support those countries wishing to embark on greener and more inclusive growth trajectories. So this body has praised how India has a response towards COVID, and where the Prime Minister's address to the nation that a package of 20 lakh crore would be, which is approximately 10% of India's GDP, would be provided for COVID recovery. And PAGE suggests of a few things we need to consider when we start looking at recovery. So for India to recover, it will be something to promote sustainable agriculture, to promote sustainable procurement, resource efficiency, circularity sections across supply chains, green jobs, and local enterprises. And this is in line with India's nationally determined contributions, the NDC, where they have set goals to ideally further propagate a healthy and sustainable way of living, and adopt a climate-friendly and cleaner path, and reduce its emissions of its GDP from 33 to 35% by 2030 from the year 2000 level. So if the money is spent wisely, we can achieve these targets. And then this is a graph from the Climate Action Tracker. So they carry out strategies and determine what is the best way of India's spending the money, the GDP package available, and how we can improve sustainability and building back better. So this is a chart just to explain what that looks like. So if the policy of the governments were very strong towards green stimulus, just by increasing plus 1.2% in green investment, we would have a strong growth towards sustainable development. And it's the same by reducing, the CO2 gigatons. And the same goes similarly if you have only a +8, then green investment, and then reduce the fossil fuel investments. So the Paris targets are here, and this is what the target is, and we are trying to follow, and this is what the target policy. We can do much better if we can improve just 0.4% of how the funding is being used towards green investment. And the worst case, as you can see, is a decrease in green investment and increase in the fuel fossil investment. So you can understand that how important it is to give direction towards the money spent towards development. And this is how this is one way to look at it. So I'm coming back to showing what the UK has to offer. So this document was generated over the COVID lockdown, which happened in UK back in 2020, and it focused on what the UK plans for economic recovery. So when they sat down together with the industry leaders, and they created a document which would be followed by which would be taken up by all the new projects for acceptance. So MMC is one of the highlights in this document, and it was very interesting when I read through it, because all the concepts which are required to achieve MMC are already mentioned in this document. And this was the way the projects would be modernized. So that means anyone and everyone in the industry will have to adapt to MMC. They wouldn't have a choice to go with the old standards and to grow their business because they wouldn't be able to take on new projects. And this has to reflect as to how you would learn how structures are built in the university as well. So it also means that MMC can be ideal for the industry as the process claims to deliver faster, higher quality, thereby reducing construction costs. So I'm just going in, I think, few pages into that document and showing you what they have defined as what MMC is. So MMC is a framework of a 7-category framework, which can be divided into the following category definitions shown below. It's pre-manufactured primary structural systems, which can be prefabricated steel elements or precasted elements. It could be two-dimensional structural systems. When we two-dimensional, we say panels or walls, prefabricated and brought to site and assembled. Then the third one is prefabricated components. When you have larger sections, you would have connections which are already ready-made within the pre-built. They are brought to site and assembled. That's another way. The fourth is additive manufacturing, which is by using 3D printing, which uses 3D printed concrete or steel. Yes, there is a steel bridge which is 3D printed recently. And then there is number 5, you've got pre-manufactured non-structural assemblies. These mean facades, then anything which the outer form of the structure, which is not taking any loads. So typically it's going to be facades and all the finishing elements within the walls in terms of UK housing, because you have insulated walls in the UK. And then the other 2 sections are focusing on how site is reducing the amount of site involvement by pre-doing work, similarly in the factory, but they're reducing the amount of manpower required to do that job by either using robotics or using methods which are improving the way things are done. And they have done a basic initial study of what the benefits of these 7 categories would do. So going back to these 5 categories, which is just up to the pre-manufacturing non-structural assemblies, they have a high capital cost of materials in the initial stages, very low site labor, very little site supervision required, and very little plant and temporary works required on site. And then the site lab process it loses a little bit of that material, a little more, there's less slight site labor compared to the pre-manufacturing approaches. And the site supervision is also reduced. Ideally, 6 to 7 is what has been happening for the past 2 to 3 years in the UK. But this is actually has taken gotten 3 to 4 fold in terms of how projects have been adopted. So they are actually benefiting from this information. So that was what COVID strategy looks like both in India and the UK, and what it would look like for India. The next part is energy sources. So very basics of energy sources we get from the sun, from wind, from thermal energy from the heat from the earth, hydropower from flowing water, ocean energy in the form of waves, tidal current energy, biomass from plants, nuclear energy, which is not completely natural, but it is manpower to generate energy. So in India, as things stand, we are, in terms of renewables, we account for less than 4% based on the International Energy Agency. And India's generation of electricity is close to 70%. So this is where we are lacking behind, and we have to understand that it is behind. And the question is, what are we going to do about it? Because the consumption of the requirement of electricity generation in India is not going to be reduced. It's only going to increase. And one way of looking at it is with solar energy, which is directly coming from the sun, which I will be explaining in a bit. And this is a policy scenario created by the IEA, the organization I just mentioned before, they have studied as to how the worst case scenario in terms of energy usage, or how the shift from coal to solar may happen over the next 20 years. So they estimate that when the start of PV takes place, it will exponentially rise to 50, and towards 35% of solar energy would be accommodated within India. So this is what they are claiming. Well, they're estimating, but we have to understand that in India, we will need 869 gigawatts of power in the next 20 years, but we would be much better than what we are right now, going from 4% to probably 35 to 40% if we could achieve that. And why I choose, so why I talk about solar is it's the most developing form of technology at this moment. It is widespread. It is, and I'll explain that in a little bit. The next slide. So solar solutions. So photovoltaics, just by the term itself, is just getting solar power from the sun. It is an elegant means of producing electricity on site directly from the sun without concern for energy supply or environmental harm. So the raw materials required is less affecting the planet as well. The amount of energy it generates is very sufficient for a lot of practical uses in the world. This has been taken due to the development of solid state batteries and storage, a lot of energy storage elements. Solar has been taken much forward now, which is at 33% efficiency. So this is, and when we talk about solar solutions in terms of structural engineering, we are looking at as building integrated photovoltaics wherever we can integrate solar panel into the building. And when I say not just on the roof, we are talking about replacing facades, talking about replacing in the future, replacing window glass as well to do this. So it's not just putting a panel on top of the roof. It's more integrated than what it is before. And I'll just in the next few slides I'll be explaining a few solar solutions around the world. One of those first examples is the Cochin International Airport in India, and this was done they started with 400 panels in 2013, and it now has 46,000 panels, and the airport is running without any power requiring from the grid. So, and this is I think the first airport in the world to achieve this. Another example is Thailand. I just need to double check if the audio is through. If you're going to play the video, please let me know if the audio is going to play.
Yes, coming.
Yeah, okay. This is Thailand solution, where Thailand has only 11% of power coming from renewable energy, and they have taken.
We try to join the hydropower and the solar power together. It means that during the daytime, we can generate the power from the sun. We have energy management system to control and balance between hydropower and solar power. This is the biggest project that in the world. $144,000 panels is equivalent to 70 football fields. This project that is suitable for Thailand because it getting more rapid to meet the target of the COP26 that the Prime Minister already committed.
So it has two applications. It's not just solar panels to generate energy. Wherever there are places with drought, where you have a lot of evaporation happening during the summer, so that's where you would use a panel like this to cover the water to prevent it from evaporation. If there is, if you've seen examples around the world, they use these form of balls, black balls, to absorb the heat, preventing evaporation. So this can be a combined solution for a place like India, wherever water is being evaporated during the drought season. And then Google's head office is using one of the next versions of BIPV, not just panels. If you look closely, they are using individual elements which are generating electricity, and these look like standard roof tiles. So it's a really elegant as a solution, and it's generating most of their power, and they have very little taking very little energy from the grid. And you can see how massive their structure is and how much time they've. Well, it's not just them. Even Apple has done something similar to their structure as well, but they are leading towards net neutrality office scenario at this point. Another example is a school in Copenhagen, and this school has accommodated an option of replacing. There is literally no paint around most of the structure. There's all facade panels with solar panels in them. These panels change color over the year, and they create a different kind of view at every point of the year, which is kind of elegant. So you're trying to achieve elegance without making it look like a robotic structure. So that's what a solar panel can do nowadays. So this panel provides 50% of the energy needs for the school, and it's a lot of savings in terms of the school's infrastructure. I'll go to another example, which is something which happens on site. So in a site, you need local generator to power your equipment, because in Hong Kong you have to follow this process where you cannot take power from the grid. In other places of the world, it is the same. So now typically it is a diesel generator, which is very noisy and produces a lot of fumes as well. It has to run close to 24 hours, depending on site requirements. This is an example of how a battery could replace all of that, which is a very quiet solution, which allows you to work at night because you get the permission to work at night because there is no noise. And this provides, it's mentioned, 85% less CO2. Now you would be thinking, how do you charge this battery? And this battery is basically comprised of smaller elements inside, and they are stored inside this, and you plug it in. And so these have to be charged and recharged. If it's taken away from site, charged and recharged. So the full cycle of the energy usage here may not be not completely sustainable, because you have transportation, which not always be an electric vehicle, could be a fuel generator. So you are not completely clean the fuel chain, transport chain, but this is a step towards that. And then the next slides are all talking about, in order to achieve modern methods of construction, there is an extent of digital understanding as well as building management system requirement as to how we need to integrate all of this to achieve this modern methods of construction. So as the methods are not particularly complicated, but how we achieve them has to be achieved with much less tolerances, as we were practicing before in our construction site. So to improve those, we have a lot of systems in place to ensure we can achieve better tolerances in design as well as in construction. So one of those requirements are BMS. So what is BMS? BMS is simply a system of managing a building in terms of heating, cooling, lighting, shading. So it just means it will manage a building. Now this typically in the traditional method, these are done by people, or have a management team. They have very recently become computerized systems, and they do the same jobs with less effort, and they're more efficient because they're able to pick up more issues very early on. So the systems, for example, the systems here and the systems that it can control here are lights, the HVAC, the air conditioning, the energy management within the building, if you have parking, if it's paid parking, and conference room meetings. So all these are talking about software applications implementations within an existing building. So there are a lot of things you may want to think about in a building, how to make it more efficient in using less energy, less water. How do you optimize the building as to put the best airflow to reduce spread of COVID if it happens within a building, or how do you improve the ventilation in a building, which is ever since COVID happened, improving ventilation in a building has been the #1 priority by many employers across the world who work in offices. So for them, BMS has become very important in terms of redesigning their own layout. So they have gone to changing office layouts just because of how important it is to improve the airflow within a building. So building management system allows you to do a lot of that. And it also helps you to pick up issues where, say, you have leaks in the pipes, or you have rust happening, or you have a cold spot in the building, or you have a not efficient air conditioning system. All these things can be picked up by sensors within the building, and it can be read by a device like an app on the phone, or it could be an HMI device, human interface device, which will help you to see, right, these are the things which are happening, and then I quickly know what I need to do to make it more efficient. So this is one way of looking at it to make it sustainable in the long term, to maintaining this without having to wait till something happens. And the other thing about the other system is building information modeling, which I think many of us as structural engineers are aware of, but may not have practiced on a daily basis. But towards an extent, anything in the word model is already a start for building information modeling. So BIM, basically, it is a set of technologies, processes, policies enabling multiple stakeholders to collaboratively design, construct, and operate a facility in virtual space. Now, when I say stakeholders, I mean clients, I mean engineers, I mean contractors. If the contracting company uses it, it means also it goes back to BMS. So it's after it's built, it's managed, and all these systems are in place, so it can talk to each other. And this is just an example of what that could look like. So you've got conceptual design happening here, which all your software models are one part of BIM. And you've got a detailed design, which is exactly part of this, but you try to do reinforcement, or you try to do steel connections, all of it done in three-dimensional space, not in a two-dimensional space. Then you create all those documents required for construction within the BIM space. So it becomes a space, common data environment, CDE. And this is where all of your BIM modeling information comes. So if anything, like even for demolition, if you have this, you would know what to destroy to make the building fall down, for example. So it's those kind of things which help improve the whole process of design and delivery of projects if we implement BIM. For MMC, it is crucial because the amount of detail required in delivering a modern method constructed building is extreme. But when it's extreme, it is fully detailed. Elements have to be done within the design, in the initial design itself, to ensure that everything else fits together. When we say everything else fits together, it's not just the structural elements. You're talking about all the M&E, that is mechanical and electrical elements. You have HVAC, the air conditioning and ventilation. All these elements have to come together. That is, for example, making sure it doesn't clash when you're building, once you've built the whole thing. And you can coordinate how these things are going to be built in stages. So you would try to find out if this part of the structure is built at this time. So this is the time the mechanical and electrical part has to go in. So you would have a more efficient construction program or a timeline to make sure that happens better. So we are forced, well, basically we are forced to do this so that we can have the best solution. So we are optimizing as much as we can within the initial stages, because once it's built, it's very hard to change any of this because of how Ideally, the structural behavior is a bit different, but not so much different. It's a bit different, but changing is becomes harder as you're trying to make it more standardized or more individual elements. So this is the part where I am fairly interested about, and this is what BIM modeling for a structural engineer in the present day looks like. What that means is the architect will provide their visual eye candy of a model of a building structure they want to achieve. The structural engineer, at this stage, in myself, when I did my projects, they were taking the two-dimensional CAD version of it, creating lines for a programming model, and that what that means is programming modeling is parametric modeling or computational modeling. And what that allows is to create a whole structure from just the CAD file without modeling one element at a time. It is completely parametric. You define the parameters such as the building has to be this tall, the building has to be this wide, the space between two elements has to be this element, and then so on and so forth. You develop a full structural model within this through this software very quickly. So what that helps us is when I had to design a building for the architect and they were doing a feasibility study, they would change the design every half hour, and we would be able to analyze and tell them if it is feasible within 5 to 10 minutes. And you will be wondering, how is that possible? That's because parametric is taking the same elements in the output and helping create a structural model and analyzing it at the same time. So it's very seamless, and by doing this a number of times, we are achieving very high reduced amount of materials. We are using more efficient designs. We can achieve much higher quality in terms of tolerances. So this is helping the structural engineer. And since I've come to the UK, I have done my version of this in the work I do as a bridge engineer. This basically is a video. So what is this? On the right side is a software called Lusas. On the left side is just Google Earth and the 3D version of it. So this is how we presented our solution to the client. I drew a model which is in 3-dimensional space for Google, and then I created this model, and this is what I was told we were proposing as a solution for the client. And now if you see that the whole structure is not designed any, it's only the truss bridge there. So I've taken that truss bridge into the boundary conditions into a Rhino Grasshopper model, if you're aware of that kind of software. And these 2 points are the only points I defined in my model. The rest of it is all parametric, and all my parameters are happening here, which is called Grasshopper. So now I've created a truss with a certain amount of base and a certain amount of width, and I can keep adjusting them as much as I want. It is creating a structural model. It's going to create a structural model now. So when I click the button to push, it is going to start drawing that bridge with the elements, with the sections included. So for me now, I just need to put my loads and run my analysis. So here I can optimize how many bays I want, what's the size of the sizing of the members. So this is happening for me, which normally would take me half a day to model this, analyze this, give us a result. This is now helping me do it in 15 minutes, the whole thing, the whole process. So that's how much optimization we can achieve by using a BIM model or the bridge engineer's approach towards a BIM solution. So I think from the both sections I've explained just now, I will just stop here and just ask if would everybody like to take a 5-minute break, or would you like to push through? Because the rest of this is mostly projects and project videos. If everybody can use a break, can anybody let me know in the chat? Anyone? All right.
Hi, David. I think we should go ahead with the videos.
Right. All right. So because I've been talking and explaining myself a bit too quickly, I think, for everybody to pick up everything. So I'm just trying to keep it interesting. So okay, let's push through.
Yeah.
So modelization of structure. So this has been the highlight of, well, basically when my career started off in design, this has been the highlight of Hong Kong initially, because we were targeted to develop a structure like this, which looks like Legos when they're built in the factory. And the basic logic is to modelize is to reduce the complexity of a system. The meaning of complexity means is just trying to standardize a building. When we standardize a building, we assume we will use the same sizes of the structure, panels, all these elements will be reused. So when you start to see that, you start thinking about this is starting to become a manufacturing process, which is called DFMA, Design for Manufacturing Assembly. So you'll start thinking about, this is coming from an existing manufacturing system, which is the car industry, which is a very good example, how successful they have used the concept of DFMA to churn out mass amount of the number of cars, or any manufacturing industry to achieve that. So we are just only following in their footsteps to achieve modelization. So the initial structures we have developed are not completely designed for manufacturing, but they are getting standardized. So the more we do it, more we are getting better at it. And we have to push for it. It's always a struggle for the client to accept it. But we are pushing for it. We are trying to show them the benefits of it. So the benefits of it are in the next slide, which is a study that has been released by the University of Cambridge and Edinburgh joint research. And this is an example of this building right here. It is the tallest building in. It's a 44-story building in London, Croydon, and it is the tallest modular structure in the UK. There is a taller one in Singapore, but that's concrete, but this is a very lightweight steel structure. This has got mass-tuned dampers for controlling the lateral effects of the building. So it's very interesting stuff. And their research by the developer themselves have said that they have used 45% less carbon than traditional methods. Now, this is in terms of material, and this includes in terms of site involvement, and this is the amount of space required on site. So all these things have contributed to achieve 45% less traditional. So when somebody asks you if MMC is good or better, this is the evidence that I would show them, because we didn't have this till 2 years ago to talk about how much efficient it is. So we had created a lot of pie charts and strategies to show graphs as to what that is. But now we have research to show this is the future of house building. And these two studies have come from two buildings. One is this one, the 10 degrees towers in Croydon, and the other one is the Valentine. It's a 10-story building, which is also using the same method. And then they were all built using the same contractor called Vision Modular Systems in 2020. And they achieved 45% carbon savings when compared to traditional construction methods. And yeah, that's the example. And then I did my fair share of research of videos of trying to understand what the Indian market has to offer. And I'm not saying that the Indian market, this is the full extent of the Indian market. This is just an interesting marketing video I found on YouTube, which is actually luring you to look at that option. There are many videos which are not enticing enough for somebody to look at it. So this is one of those examples. And this is
आप अब तक टोरंटो को टिन शेड के बाप के नाम से जानते हैं, पर क्या आप जानते हैं इससे हाई एंड लग्जूरियस कंस्ट्रक्शन भी संभव है। ये 2 फ्लोर का फार्म हाउस बना है टोरंटो से।
This has been completely done as a steel structure with their proprietary Toronto panels. I have no affiliation with the company. It's just their marketing video, the amount of effort they put towards this video is very interesting to me. That is why
आपको जानकर आश्चर्य होगा कि ये बिल्डिंग बनी है मात्र 72 दिनों में। आज हम आपको बताएंगे कैसे बनी ये बिल्डिंग इतने कम समय में। एक सरप्राइजिंग फैक्ट ये भी है कि इस पूरी बिल्डिंग को बनाने में सीमेंट के एक कट्टे का भी इस्तेमाल नहीं हुआ। पूरी बिल्डिंग बनी है सिर्फ प्रोंटो से। सबसे पहले स्टील स्ट्रक्चर इंस्टॉल किया जाता है। यह स्टील स्ट्रक्चर ही बिल्डिंग को मजबूती देता है। एयरपोर्ट जैसी मजबूत बिल्डिंग्स भी स्टील स्ट्रक्चर पर ही आधारित होती है। स्ट्रक्चर बनाने के बाद प्रोंटो प्री फैब्रिकेटेड पैनल्स इंस्टॉल किए जाते हैं।
Please do notice the level of
इस बिल्डिंग
safety
में
on this
दीवारों
site,
के लिए
and
प्रोंटो
this is one of
सीमेंट
those
फेसिंग
sites
पैनल्स
where,
का इस्तेमाल किया
although the
गया है।
marketing is very good,
प्रोंटो पैनल्स जरूरत के
safety could have been better.
अनुसार कस्टम
Safety
साइजेस में
procedures
फैक्ट्री से
taken
ही
to develop
उपलब्ध
these
कराए जाते
structures
हैं।
are
इस
more
बिल्डिंग
risky
में
compared to a
20
typical project
फीट तक
because you're not going
की
from the
लंबाई
ground up,
के
you're
पैनल्स
achieving
लगाए गए हैं।
much higher, much earlier. So
इंटरलॉकिंग जॉइंट से बिल्डिंग झटपट शेप लेने लगती है। वहीं छत के लिए मेटल फेसिंग रूफ पैनल्स काम में लिए गए हैं। रूफ में स्काई लाइट्स का प्रावधान दिया गया है। स्काई लाइट के इस्तेमाल से बिल्डिंग के लुक्स कई गुना बढ़ जाते हैं। विदेशों में इसी तरह से मजबूत व इको फ्रेंडली कंस्ट्रक्शन कई वर्षों से किया जा रहा है। फ्लोर के लिए प्रोंटो फ्लोर पैनल्स काम में लिए गए हैं। इसके बाद टाइल्स, खिड़की, दरवाजे एवं ग्लास वर्क किया जाता है और साथ ही साथ इंटीरियर वॉल्स भी इंस्टॉल की जाती हैं। इस बिल्डिंग की वॉल्स पर विट्रिफाइड टाइल्स लगाए गए हैं। आप चाहे तो स्टोन, टेक्सचर या पेंट भी लगा सकते हैं। भूकंप की स्थिति में ये स्ट्रक्चर कन्वेंशनल बिल्डिंग के मुकाबले कहीं ज्यादा सुरक्षित है। आइए अब देखते हैं इस बिल्डिंग को अंदर से।
Right. So this is deviating away from the structural part. So I'm going to go to the next slide now. And then this is another example of another modular project, but this is in my neighborhood where I live now, called Montstow in Cambridge. This is a grant received by the UK government, from the UK government, to a developer to do modular housing in this area. And this is, they also have marketing videos, and you can see that. Please notice the level of safety and the number of people on site, as this is what is supposed to be.
These are the first of 406 MMC homes to be delivered on Homes England land at Northstowe. Thanks to our groundbreaking £90 million deal with Japanese house builders Sekisui House and regeneration specialists Urban Splash. We said we'd support MMC through investment and on our land. We said we'd diversify the markets. Now this urban village, part of a 10,000 home new town, will be part of our MMC research study, driving industry innovation.
They are around 5.5 by the 10 or 11 meters in size. They're wider than the truck. And they have to use special vehicles to guide these on the main road. In Hong Kong, there is a bigger struggle. It's only 3.5 as the limit, but the length is 12, and you've got a height restriction of 4.7 if you use a low bed trailer, or you have.
Together, we're making homes happen.
You can see that the solar panels are just panels, but they're integrated when before the site is built. So you can see within a day that is one house, the 2 stories. Within a day that is delivered and built. So when these are manufactured in this in the factory, the ground conditions are being developed. So it happens simultaneously. So you can imagine how much time you save in achieving such a solution. So we will go on to the next one, which is going to Hong Kong, which is the projects I've worked on. So this is basically, as you see, a quarantine center for quarantining people who have been tested positive for COVID. This is very near to the airport, and this is where you will be quarantining for the 21 days if you end up in Hong Kong with positive result. So this design in 2020, when COVID happened, was designed to be built in 90 days. And as you may think, it's much of a challenge. So the first 700, the total is much more than that. The first 700 was done in 90 days. And what that meant is I was the lead designer. It took me 36 hours to design. It's not much of a design, but the point is, it is a very reused, standardized system. And so we have developed a design which incorporates all the modular elements. And the other part of it is it could be dismantled later on to form another structure like a residential building once COVID is managed within Hong Kong. So these would become temporary residential. These could be removed after they're built. They could be removed, taken to other places within Hong Kong and provide accommodation to people who require it. And because of COVID, China was closed down because China is usually where most of the product is built for Hong Kong. Fabrication in this case was done in Malaysia. And the first modules were sent, first batch was sent in 60 days. And the total phase had 1,200 units. So the foundation, common services were all being developed on the ground whilst this fabrication was happening. And so the thing about 36 hours is we have to get approval. Approval takes a bit of time. So the design was 12 hours, getting approval was 24 hours. That is the amount of time spent on the design. And this is again the contractor's video. And the requirement of having seen these videos
the Penny's Bay Quarantine Center
is because it's very new and clients need to
temporary
adopt it.
quarantine facility established by Modular Integrated Construction Method, MIC. Designed with integrated building services and finishes, the Quarantine Center is composed of interconnected modules. With a modern interior finishing, every module comes with basic necessities and the living accommodations for its occupants. Before it is transported for installation, each module is assembled off-site at the Lu House's factory in Chongqing. Modules are fitted with a concrete slab base, then steel structures are installed with certified fire protection board with an aluminum exterior finish to create a body shell. From here, the interior and MEP are built and installed. From the concrete slab, steel frame, MEP system, to the interior fitting out of each module. Every part of the module is assembled with quality and care. After its initial assembly in the factory, the modules are ready to ship for installation. During the installation, the module is lifted into place and will be interlocked with the other modules to create a block. Staircases and corridors are built as MEP installation begins as well. After an on-site quality check and commissioning, the units are ready to use. Each module can also be uninstalled and reinstalled to suit different designs and location change.
This is what I mentioned. Can be designed to be removed. So this was our contractual requirement to create a structure which can be dismantled when required. Similarly, another contractor for the same project, this design is again the same thing, but this is their again promotional marketing video. This is the next phase. and they had improved their manufacturing process. So they have robotic hands, then they have a lot more procedures to achieve better quality. The already quality is very high. You can do better by automating many things in this process. So you can see the amount of BIM involvement. They're creating all the on-plan MEP, mechanical, electrical, plumbing services, then all the full site completion, construction phases. So these are all. This is basically, BIM has 8 Ds. So this is where the 4th, 5th, 6th dimensions come, where it's about time, costs, and as well as structural analysis, which is part of the requirement BIM. So they're just trying to show you this is what they've analyzed, this is what is being done. That is the level of detail they have gone through to achieve this. And these are not very big structures, but the amount of detail required to achieve that is high. So the tolerance level for these buildings, when we are designing them, our specification is 2 mm horizontally, vertically. They contract to achieve that, and in 2 stories it is still feasible. When you do 17 to 18 stories and you go 100 meters above, that is where the challenge happens. But it is still being done. So this is the first tall building. This is 17 stories, so it's around 150 meters, including concrete structure. And the first this was the first of its kind in Hong Kong, and had a lot of challenges. So the way we had to develop this structure was initially, as you can see on the right side of the screen, this is how the system works. These are modules, which are individual boxes, as you've seen altogether. And this is an in situ slab, which is a flat slab, and they are casted on site. Same goes with the in situ core. The core structure is basically 2 lift cores. This is a staircase, and this is a lift core. And these are the 2 structures that are going to take all the lateral forces from wind. And Hong Kong is not subject to earthquake, so it's just basically typhoon level wind, which is 98 meters per second or 300 kilometers per hour wind speeds. And these slabs, they tie this core and these modules together to form a single unit. So that's how the structural behavior of this building works. And I will just show you the I can't play the video. Okay, I will skip now. I'm just trying to show what the construction sequence is, but I will show you that in another video. So this project, as you know, is the first of its kind, it is in the news. It was in the news, and you can see how it's being built.
About 80 to 90% of finishes and the furniture installation will be prefabricated, pre-installed in the factory. It's first of the kind in Hong Kong.
these are 25-ton capacity tower cranes, which also is rare in the world. The first two were in Hong Kong for this building, and then Hong Kong had to procure more.
This is a kind of construction method with enhanced construction efficiency and safety, as well as the productivity. Each crane can install 15 units per day.
So 15 units means
We
30
can install
units.
about 30, because we have made use of the two cranes.
And one floor only has 30 units, so the
And
construction,
we can install all the units within 90 days.
the whole structure is built in 3 months. Structurally complete, not finishes, but structurally complete with 90% of the modules finished. The project was handovered by October as completed to the client. And then again, this is a construction sequence for a project which I was the lead engineer on. Because once we started doing modular buildings, all of this is in being to show these are all concrete in situ structures, only the structure above. This is the core. The modules are the ones which are going to come in. And this is 30 stories. When you have 30 stories, your wind load, lateral stability becomes even more critical. And then if you look here, there is no slab stitching, so you can think about these modules separately at the edges of the outside of the base. So these areas, the edges, so these become very susceptible to lateral forces. So stabilizing that becomes our connection takes more stresses, which is again you have to design for. But the technology has improved so much that even the lateral stability walls can be done precast. Fine. So this is the last two slides. So you've seen so far the MMC projects focusing on modular solutions, and then you've seen energy solutions of implementing solar panels within the building. So now these can work together to form a very excellent and elegant solution, as I would recommend. And this is a slide which would represent what the next 15 to 20 years would look like in the future. So this was the article written by a company called Arup, and they did the research and identified what the future of the energy storage systems would look like. So there would be a widespread adoption of energy storage technologies. What that means, it's not only just batteries, it is for heat, and it is also, you still have fossil fuels at this stage. More countries will take a challenge to ban hydrocarbon fuel bans. That means less using of fuels. They will be forced to use low carbon solutions like nuclear or solar was created by renewable sources. And then homes will start to look at individual dedicated battery solutions, so that each of your homes or your apartments will have batteries in them which will be storing solar energy, because the amount of solar energy you can generate will be more than what you can use in some situations. So you need to store that, and you use that during the night when there is no energy from the sun coming through. And then because of the situations that are happening around the world, such as the war in Ukraine has created a fuel shortage supply in parts of the world. So to avoid situations like that, resilience here is creating diversity in terms of having different kind of energy solutions, offshore, nuclear. So if once you distributed it, if one doesn't work as expected, you have more resilience in how you distribute energy. And then the other thing you would consider, it's not always positive, so all the actively usage of batteries or storage solutions will have to be disposed of once they reach their end of life. So that is something to think about. So how do you take care of that? You'll have to create systems which allow proper disposable or even recycling of these elements. So new battery technologies which can use renewable or the existing batteries to form a new solution, something actively being researched upon. And this is the question now, as structural engineers, one must ask themselves is, you've seen MMC, if you've implemented, if you've not implemented it, you have to do that first. And then again, you have to look at how a sustainable solution looks like. So that can be a modular solution. A modular plus solar panel solution would be even more amazing at this point. That is going at the peak. So that the research is happening, and it's best to get on that train. And this is the last slide. And this is just a video of somebody. His name is Ashraf, and he's the president of the CSI, the software company who makes ETAB and SAP. And he presents a video. Well, he created a video to present to all of us to make us, appreciate our career. I'm just playing this video because I watched this a number of times throughout my week to keep me motivated to do the things I do.
Do I love New York or do I love New York? I mean, this city is literally the testimony to the grandeur of our profession. Just look around. That's all your work, every solitary building. I mean, you do stuff that actually makes things stand. When you start thinking about that, it's miraculous. I mean, it's only because of you that we actually have an economic infrastructure. You give people ways to arrive at work and then to work in an amazing building like this one, which doesn't sway around in the wind and make you seasick. These things are just taken for granted. People are totally blown away when they find what you do. I mean, when people ask me, what do you do? I say, I create mathematical models of building them bridges in the computer memory. I blow wind on them, shake them with earthquakes. And the software tells me which portions of the building are going to break apart, so I can fix them before it's even built. And they look at you. Are you some kind of a genius or what? But you see, people don't know. People have no idea what we do because we don't invite them. Our conventions are about us. We all get together, talk about the amazing things that we do, pat each other on the back and go home. Meanwhile, outside, nobody has any idea what we do. We need to invite outsiders. Bring them to a party. Make them feel amazing. When they come to an event where they come in and look, oh my God, look at this event. It's better than Hollywood and I was invited.
Party is to celebrate our amazing profession, but more importantly, it's to celebrate every one of you. The beauty about your profession is that you make life better for all of humanity on a daily basis. So, let's have an incredibly big hand for all of us.
I don't know how many of you have heard of the name Simon Sinek, but he talks about the concept of belief and how important is it to have beliefs. When you're sitting out there alone, you and your thoughts, do you really seriously believe that your profession is actually a gift to humanity? Do you really believe that? Because I do. I'm so convinced. I mean, I come to a city like New York or Chicago and I just look around and marvel at all of these things that are just standing. And the second thing is, it's important to get out there and talk about your beliefs. Because you see, when you talk about your beliefs, something magical happens. You attract people around you that believe what you believe. And why is that important? That's important because when you're surrounded by people that believe what you believe, they will do what you want them to do without you even asking them to do it. Not because you want them to, they do it because that's their belief. Believe that you are actually creating something that changes humanity or serves humanity or is a gift to humanity. As Steve Jobs would put it, something that puts a dent in the universe. And when you get out there and talk about your beliefs with passion, you convert people that don't even believe what you believe into believing what you believe. And at that point, you will get paid what you deserve to be paid, not because you're asking for it, because that is their belief. They believe that you deserve it. But it has to start from you. You've got to have a sense of belief that you get out there and talk and celebrate.
All right, so that is the end of my presentation. I will be taking questions now, and thank you for going through that, even though it extended a bit beyond what I expected.
Thank you very much, David. I also felt motivated after seeing this video. Thank you very much. And throughout this session, yeah, please, David.
Yeah, sorry. So I'm just trying to stop the video. If the host can stop sharing, that would be great. Thank you. All right. Thank you.
Yes. Yeah. So thank you very much. We got to know today that how low carbon structures paired with low energy technologies ensured cost-effective and sustainable solutions for clients. It was wonderful, David. Also, we learned that how building back better, how to mitigate greenhouse gas emissions towards a green recovery of our Indian economy. We also learned about 7 category definition framework for modern methods of construction, which spans all about pre-manufacturing, on-site manufacturing, and post-installation as well. And also very interesting video, which I was very much impressed that regarding modular project category. It was very interesting project that was in Hong Kong Quarantine Center, and I was amazed to learn about that design was in 12 hours and approval took 25 hours and execution 90 days. Amazing, Finn. It is amazing. Yeah. Also, I'm just trying to summarize. We learned about building integrated photovoltaic systems, and definitely India is utilizing all these systems as a building facade, glass facade systems. And we also learned about building management systems, which integrates all heating, cooling, ventilation, lighting, all MEP, aesthetics, everything in one place, including building management. Also, we learned about BIM, that how intelligent buildings can utilize 3D model-based processes under common data environment. And we also learned about modularization of structures. That's where we learned about that amazing project of Hong Kong Quarantine Facility, apart from other projects. So thank you very much, David. It was very, very interesting and informative session. And the last video was really, really, very interesting. I feel motivated most of the times, but yes, my belief in my profession got reinforced after seeing this video. So thank you very much, David. Now we are open for question and answers for the queries of the viewers. So let me take one by one. Our audiences have put through in chat box. So first question is from Mr. Syed Hashim Ali regarding solar panel steel structure. So his question is, what type of steel structure will be preferred David?
So the question is basically the question is based on the solution you want to achieve. If you want to support a solar panel and then you want to create a steel structure for that panel, it could be anything because of how solar panels are. In some cases, you wouldn't even need a structure because, like I showed you the Google example, it is just a roof tile. Similarly, in future, very near, it is going to be stuck on with 3M tape. That is the level of development that is happening. So you wouldn't need a structure to support this panel altogether. You would be looking at trying to figure out how do you support the existing external finish of your building. And that would be the same thing you would be using. So all these developments are trying to only incorporate the existing design practices. They are not trying to create new, more challenging scenarios for structural engineers. I hope that answers the question.
Right. Yeah, sure. Next question is from Dr. S.P. Anjuri. Why still in India, BIM or any other platform not yet in practice by all the experts? If few and few not in a team, makes no difference. His point is, I think he's right.
Yeah, so I will give you it makes no difference, but I will give you a very good example, which is my own career. I was in this situation 2 years ago where I did not get any help from my employer or the team to develop BIM. I spent my time, my weekends developing a BIM solution, and then in meetings, I would bring this up show it to the client. The client was always impressed. And the next time we have that conversation, they always come back to the BIM solution. So it is not just up to waiting for somebody to tell you to use BIM. If you think it is beneficial, take the initiative to start doing something about it, build something, show it to people. Once people see it, then they will see its value. So this is where this has been this is still my situation in some situations where projects do not require BIM, but I see the importance of it. I incorporate it before people know, because if the time taken to achieve BIM is the same as I've proved with my 2-dimensional CAD drawing completion, and then we just go out, and then later on when they come to check the design, we show them the model, and then they're very surprised to see we can achieve this in the same amount of time. So I would say, rather than say makes no difference, go ahead and make the difference.
Exactly. Another question is from the same Dr. S.P. Anjuri ji. Can you please give us some numbers regarding reduction of carbon footprint compared to RCC to any other materials? So
I wouldn't have exact information, but I can tell you where to go and find it. So the iStruct in the UK, Institution of Structural Engineering in the UK, have released a document which gives you, which is a spreadsheet, which is a calculator of exactly what you are looking for. So if you were to compare, you would get that. If you were to do framing, and then you would to consider the tonnage, and then you would get comparison values of carbon footprint. You will get exactly the same. So this is one. Every employer in the UK has now released one themselves. So I could, if that is something somebody wants, I can download it and send it off as an email, and then you can share it. But this is easily available information. So how I come across this is basically when I started the first time, I used this formula, and then later on, if you've seen my BIM, the modeling I have done, I've incorporated in my parametric solution. So I stopped looking at it. I just tell it to tell me when I hit a good percentage of carbon footprint reduction. So that is how I use it now. So I've already gone beyond the numbers, and I tell the software to tell me if it is better for me or not.
Fantastic.
So how much U value? So this is so what I'm trying to say. This is not the complete of my expertise with these panels. Is like I mentioned, right now the best technology available with solar panels is providing 32 to 33% efficiency, and that is what we can look at. I cannot comment on the U values because I'm not the person dealing with it. I deal with people who do this, and with the working in WSP, I work with the University of Hull right now to incorporate these solar panels into our new projects. So this is the input I put. And
But overall,
The next
33% ideally.
Yeah,
In
so
ideal
the
conditions.
technology allows 33% efficiency.
Yeah. Right. Yeah. So what is the design life considered for the volumetric constructions generally?
Yeah. So this is a question which is put to us even by the Buildings Authority, where we say the same thing is we have not changed how the materials we use for construction or design. So our codes and standard practices are exactly the same. If you are designing a building, it is to stand for 50 years, and we have to achieve that. Most of our, and the only thing we are doing is from our designs, we can say it will last much longer because these modular elements have to survive the transportation load case, which is more difficult than the permanent load case. So where you have traffic, where you have dynamic loads, this is where these modules are actually failing in the initial studies. So our designs are much stiffer. So, and for your answering your question, that question is, we are following the same codes. We haven't changed any of the codal requirements. The estimated years are the same. The way we check connections and critical elements, we provide panels to check based on the asset management team. They will check it, but we provide locations to check the condition of the steel or the concrete or the reinforcement, wherever it is required in the design.
Yeah. So next question from Mr. Chopsy. Why BIM is not used in India in most cases? I think like myself, let me answer David to this question. I belong to Larsen & Toubro, and we are utilizing BIM very frequently, almost in all projects. Like I'm currently in airport project, and we are utilizing BIM. You can also now share your experience.
So like your experience in the airport. So when the project is very large, it is very hard to manage it.
Yeah.
This is why BIM is very helpful.
Exactly.
So when you say, for example, you want to do a small 1-story or 2-story house, you may not need it. So the question is, what is the level of construction that is happening in the industry? Are you doing MTR projects or airports every day, or are you doing houses every day? Depends on the sector as well. But saying that, if you are a developer of a housing, residential housing, it is ideal to use BIM, because we are using BIM in smaller projects to identify how much solar panel area, depending on how much sun we get on a daily basis on that piece of land. So we are doing parametric studies to achieve this kind of information. So there we are using BIM. So it may not be specific to the structure. It may be the overall planning uses BIM for a point. So yeah, that is how.
Which facilitates overall design and construction, in turns reduces the effort in going into the clashes and all. It depends how intelligent building you are designing, in terms of interfaces of different services. Yeah. So next question is from Mr. Hafiz Zain Saeed. Without a core, can we still able to transfer gravity and lateral forces using connection in load-bearing concrete modular buildings?
So the question is, you have to design for it. So there is an example of us designing for it. So a core doesn't have to be a core. If you want this to work as a frame element, you have to design these connections. But the issue at this point is, if you design these connections to take the lateral forces, these connections will become very big, and then it will lose its aesthetic, or it may look way too big for it to form as a connection. So this is why using a lateral system is ideal. You're trying to the idea is to optimize the behavior of the building. So you're trying to put small boxes which are working together. So you would want a system. It doesn't have to be concrete. It could be steel braced systems. So there are many ways to achieve this. You can put them within the module, like for example, up to 4 to 5 stories, you don't need a lateral core if you can provide sufficient steel bracing within the module itself. So you can achieve it. It's just if you want to do a 150-meter building, you will definitely need a core, because there is no system available as of now which can build the building without that. So that is I hope that answers the question.
Yes, precisely. So next question is, the precast industry and the modular are to use different codes of design, as the behavior of modular building is different from precast structures. However, limited studies are available, especially on the connection for high-rise modular buildings. Your thought, please.
So if you do the research right now, I will just suggest that the Singapore building department has released a document which is free for all, which has all the standard connection designs for concrete and steel, which they have tested, verified, and have suppliers who accept these connections. They're selling these products. So I could send you a link to that, or you could find it in Google. Just it's in the buildings department for Singapore. In some solutions, we have taken that for the Hong Kong buildings. We have suggested. The thing is about concrete buildings in terms of modular, it is you have to form stitches and you have to point reinforcement ties in between. So these all details are available in this document. It's very clear, and I have used this in my designs as well. So it's all there. You have to do the research, like I say. So most of the time, because it's new, it is very hard to find such research. There is another document which is created by the university in Australia for how to identify whether a building can be modular or not. So that is even a bigger document to look at.
Good. So many sources of information are already available. It's only the thing is we don't know.
Yes.
Yeah. Exactly.
So
Yes. Right.
this was most of my job, research. So I have to know.
So thank you very much. Yeah. Next question is from Mr. Rushikesh. There was a soft story in one of your projects, but we have studied that it should be avoided. How you have dealt with it?
I don't understand which project was the soft story. If Mr. Rishikesh can mention what it was it 2 stories? Was it 5 stories? Then I could. Well, if you're talking about the prefabricated solution, the Indian solution, if that is the one, then like I said, that is just a marketing video. If it's another one, if you can put in the text, then I can explain that if you have the reference to the project.
Yeah, Mr. Rishikesh, if you can put on the chat box what you are referring, will be easy for us to answer. Or Mr. Vikas, if we can unmute him.
Okay, ma'am.
Yeah.
He think it was Hong Kong project, right? So, is it the 2-story quarantine center?
Hello.
Yes, Mr. Rishikesh, you are now. Yeah, please.
Yes, it was a tall story, I think 70-story modular structure.
17-story modular structure.
In Hong Kong, you said that it was your project, you was involved in that project.
Yeah. So when you say soft story, are you talking about the columns on the outside?
Yes.
So exactly. So when you look at it, it looks like a soft story. So when you have a core in the center, and then you have a transfer slab which is 3 meters deep, the whole system is working together. So if we could put columns outside just to work without the lateral function, because the transfer floor is just when the modules start. So that is that project, it was 3 meters deep. That is connected to your slab and these individual elements and the lateral core system. Now, in the concept, it is that slab, that lateral core system is taking everything. That is the design assumption. So there is actually no soft story. As long as we design that the shear core is taking all the load, then we can put columns on the outside and the inside as we want, because we are assuming it is taking no moment there. Is that because basically soft story means there is no lateral capacity, but in this case it is tied so much. So that's why I explained that slide, the lateral stability. So this is what it looks like. So now when you look at a building, now you may think the next time you look at this building, if you put a lateral system, then you may not need to have, bigger columns or bigger movement connections at every corner. You may consider this shear core to do everything. So that may help in your next time you look at a design like that.
Yeah, Mr. Rathi has got his answer. So I think the last question of the session is, most of the works are steel connections requiring frequent maintenance, and limited research is there for in situ connections for load-bearing modular walls. It is more durable.
Okay, so the reason why we have proposed steel connections, well, basically is how the project is delivered. We are doing lightweight 22-ton modules to lift up on a building, so that to achieve to keep it within 22 tons, we had to use steel. Otherwise, the size of the module from 3.5 by 12 would become 3.5 by 4, and then because concrete density is much higher. So when you say steel requires frequent maintenance, you have to understand that your existing steel connections, do they also require existing maintenance, or are you checking them visually? These existing buildings is built around the world. In bridges, we do vibration independent checks based on the vibration, but many steel structures we are not really checking, or we are not checking in a way that it is a very critical thing. So we are designing these connections accordingly with self-locking nuts, so on and so forth. So when we say it's not durable, it's just we are designing for it. And then when you talk about fatigue, we specify steel, which is S355, which is the strength, and then you got J0, which is basically can take a lot of fatigue. So that is the kind of specification we provide. So we believe that it is as durable. We would believe at this stage, because the concrete has to be very thin, you would say steel is more durable than concrete at this stage.
Right. So by this, we have come to the end of this session. And on behalf of ISTRAC team, our audiences, and on my own behalf, I'm glad to express our vote of thanks to you, Mr. David. And we also are thankful for accepting our invitation for delivering this lecture on modern methods of construction. We are also very grateful, and we also wish to express our gratitude to you for inspiring present generation actually towards the world which is full of opportunities in current scenario, and where with your proven analytical insight, present generation is further motivated towards adopting methods of modular construction in India also. Also, we are inspired by your technical expertise and command on the subject. Thank you very much.
Thank you everybody. Thank you. Bye.
Yeah.